Smart Culture, Mathematics.
Let's recap the definition of an arithmetic sequence. An arithmetic progression or an arithmetic sequence is a sequence of numbers such that there is a common difference between the consecutive terms that is constant. So there is a constant difference. If we take a look at the sequence 5, 7, 9, 11, 13, 15, we can say that this is an arithmetic progression with a common difference of 2. The difference between 5 and 7 is equal to 2. The difference between 7 and 9 is equal to 2. The difference between 9 and 11 is equal to 2. The difference between 11 and 13 is equal to 2. And then the difference between 13 and 15 is also equal to 2. So this sequence is an arithmetic sequence since there is a common difference of 2. And this common difference can be represented by the letter D. Let's take a look at this example. We have a sequence 3, 6, 9, 12, and 15. So what do you think is the common difference here? Well, let's see. So the difference between 3 and 6 is equal to positive 3. The difference between 6 and 9 is equal to positive 3. The difference between 9 and 12 is equal to positive 3. And the difference between 12 and 15 is also equal to positive 3. So D, the common difference in this case, is equal to 3. Let's take a look at the next sequence. Here we have 7, 2, negative 3, negative 8, and negative 13. So as you can see, in this case, the numbers are getting smaller and smaller. So that means the common difference will be a negative number instead of a positive number. So what is the difference between 7 and 2? The difference here is equal to negative 5. What is the difference between 2 and negative 3? Again, the difference is equal to negative 5. What about negative 3 and negative 8? Here the difference is also equal to negative 5, and then negative 8 and negative 13 also has a difference of negative 5. So the common difference D in this case is equal to negative 5. Here we have another example. Calculate the 10th term of the following sequence: 5, 8, 11, 14, and 17. So what we'll do first is we'll determine the nth term, the rule for the nth term of this sequence, and then we'll use this rule to determine the 10th term. So let's start by writing down the formula. Tn is equal to a plus brackets n minus 1d. We know that the value for a is equal to 5, and we have to now determine the value for d. So the difference between 5 and 8 is positive 3. The difference between 8 and 11 is positive 3. The difference between 11 and 14 is positive 3. And the difference between 14 and 17 is also positive 3. So the value for d is equal to 3. We have the value for a, we have the value for d. Let's sub this in. Then we have 5 plus brackets n minus 1, 3. Now we have to multiply the 3 with n and negative 1. 3 times n is equal to positive 3n. 3 times negative 1 is equal to negative 3. 5 and negative 3 are like terms. So the rule for the nth term will be equal to 3n plus 2. Now we want to determine the 10th term. So we'll sub in the value of 10. So instead of writing n, we write 10. So we have 3 times 10 plus 2. 3 times 10 is equal to 30 plus 2 is equal to 32. So the value of the 10th term is equal to 32. Let's say we had a value 155 and we know that it is part of the sequence, we just don't know its position. How can we go about determining the position of this term in the sequence? So what we do is we write down 155 is equal to 3n plus 2. Now we want to solve for n because this will tell us the position of this value, of this term. So what we do is we want to get n alone. So we take over the 2 to the other side. Then it will become a negative 2. So then we have 155 minus 2 is equal to 3n. The next thing that we want to do is we want to get rid of this 3 because we want to get n alone. So we'll divide both sides by 3. 153 divided by 3 is equal to 51. So 155 is the 51st term in the sequence.
For online tutoring or additional resources, visit our website, www.smartculture-education.com.
Subscribe down below. It's easy.